Okay, here we're going to rewrite the sine of inverse cosine of x as an algebraic expression in terms of x. Right now this is a trigonometric expression because we have trig functions, sine and inverse cosine. But we just want it to be a regular algebraic expression. Well, to start out with, let's let, similar to evaluating inverse trig functions as we did in the previous videos, let's let y equal the inverse cosine of x. Take the cosine of both sides, we get the cosine of y. The cosine of inverse cosine x is just x by the nature of inverse functions. So if we just draw a little this is positive value, so I'm drawing it in the first quadrant. So our angle y, cosine, think of this as x over 1. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So what is this? Let's consider this missing value a. So a squared plus x squared equals 1 squared by the Pythagorean theorem. Subtracting x squared, we get a squared equals 1 minus x squared. 1 squared is 1. Take the square root of both sides, and we get the square root of 1 minus x squared. Now, technically, this is a plus and minus, because when you take the square root of a square, you got to put a plus and minus, but we're only using the positive portion because we're talking about distances here, lengths, and we don't usually talk about negative lengths, so we're not worried about the negative square root. So this missing side is the square root of 1 minus x squared. All right, now we've got our triangle. We started out by letting inverse cosine equal y. So this is the same as the sine of y. So now, evaluating the sine of y, here's y. Sine is opposite over hypotenuse. We get the square root of 1 minus x squared over 1, or this is equal to anything over 1 is itself, so it's just the square root of 1 minus x squared. And this is the answer to this expression.